Let's talk about QuerySurge and resource consumption. Of course, when you use QuerySurge, you're asking the back end of QuerySurge to do a whole lot of different tasks. So as soon as you kick off an execution, you're making memory requests and asking for processing on both the agent, the database, and the QuerySurge app server. So once this happens, what's going on and how do we adjust for it? Let's take a look behind the scenes. On the QuerySurge server, we're going to look at a couple of different things, including the memory allocation for the app server, the memory allocation for the agent if it happens to be in the same place as it is in this example, as well as usage of disk during execution. Let's talk about the app server first. We're on a Windows box, of course, so we're just going to go to the standard deployment location. And that'll be QuerySurge, Tomcat, and bin. And what we've got to look at is this QuerySurge Tomcat w.exe. Ignore the other exes in this folder if there are any. And this generally has to be run as administrator. And once you run it as administrator, you'll see that the General tab here allows you to stop and eventually start the QuerySurge app server. Let's stop it so that we can play with its memory allocation. If we go over to the Java tab here, we'll see that the heap memory allocation is only 768 megs. That's our default allocation. And the reason we ship with that relatively small amount of heap is because we have no idea what people are going to be deploying their trials on. So we keep it low in case they're deploying on a relatively small box. If you've got lots of memory to burn, for example, if you're deploying just the app server on an 8 gig box, there's no reason to keep this at 768. Why not raise it to 3 or 4 gigs or even a little bit higher? And all you have to do in order to do that is to just change the amount of RAM available, hit the apply button, and then go back and start the app server. Okay, let's go now and look at the situation with the agent. And the agent has a similar set of considerations. And those are displayed on the front of the agent console. Now, the thing to point out here is that this is not the agent. This is the agent console. It's a little application that talks to the agent and displays key information like status and basic parameters. So the thing that you can play with on the agent is this agent heap size. And again, if the agent is deployed on a box with lots of memory, then you can set it up from the 1,000 megabytes that we normally default deploy with to whatever value is reasonable. Once you do that, you'll get a message saying that you've got to restart the agent in order for this to take effect. And so then you just have to go and stop the agent service. Wait till the stop status comes up, and then you'll see the console inform you that the agent service has stopped, and now you're ready to restart the service. Let's just talk for a few minutes about the effect of disk availability and disk usage on QuerySurge. The thing that needs the disk, of course, is the QuerySurge database, and it uses it for two reasons. One is for data persistence over the long period, in other words, quote-unquote permanent data storage, and so that's something that you're going to have to be monitoring to make sure that you keep the amount of data that you're storing long-term reasonable within the range of the amount of disk available to you. The other thing to be aware of, and this is quite important, is that QuerySurge will consume disk on a transient basis during execution. It will possibly decide to use disk instead of memory for certain calculations. And so that means that you can use up considerable amounts of disk during execution that will not be used after execution has ended. So what that means is that in a situation like this, where we've got about a terabyte available total, and we've got 535 gigs available, that might be great for running our normal runs, but if we run an exceptionally large run, where maybe we use up, say, another 100 or 200 gigs on permanent storage, so we're up at 500 to 600 for permanent storage, and then we use up more than the available remaining disk during the execution will stop, it'll fail with a fatal error, and it will probably give you results that are inconsistent because the database ran out of disk during execution. And there's not a whole lot we can do about that. The thing to be aware of is that all of that consumed disk space that was transiently used during execution will be automatically erased when execution fails. And so you'll go back and you'll look at your disk and it'll look something like this. And you'll say, well, I've got all this space available. The run must have run to completion normally, and it hasn't. So especially when you get to either very large runs or closer up to where your disk consumption is 80% or higher, be very careful about watching what happens during your executions, and be very sensitive to whether executions that seem to run one way at one point now have changed the way they've run. Because that may be a sign that that you've used up all of the disk space during execution, and while that won't be readily apparent after execution is over, it gave you inconsistent analysis of your data. Okay, those are the three critical factors in terms of resource consumption for QuerySurge. Just to review them, the heap consumption of the app server, the heap consumption of your agents, which typically will be deployed on boxes in a hub and spoke relationship to the app server, with the app server on the hub, the agents on the spokes, and the amount of disk space available to the database. Memory is also very important for the database, but the database isn't working under the same constraints that the app server and the agent are running under, and it will take all of the available memory that it needs in order to try and do the jobs that are assigned to it.